Hello my dear friends, welcome to BYJU'S exam prep. In this video of daily dose, we will be talking about wedge friction. Now, why I have taken this topic is because wedge friction many students do feel difficult to understand, right? So what we'll be doing is we'll be doing the analysis of wedge friction in the most simplest way possible. And for more proper understanding, please do watch this video till the end. Right now, if I talk about wedge friction, the word wedge means it's nothing but a triangular shape that you might have come across in your many practical applications, right? It could be parking the vehicle in the hill stations, or if you want to lift a very heavy block only by applying a very small amount of force, we can use this concept of wedging, okay, or wedge friction. Now, how we can use this? If I try to explain, let us suppose this is a wedge, okay. This is a wedge shaped or wedge that we are talking about, and this is your heavy body, okay. So what we're doing is this P force that will be required to lift this heavy body having a weight W will be far more less than that of the magnitude of W. The reason being because the wedge will be helping us to lift this body in a very normalized force, and also the friction also plays a vital role because the friction will be allowing the this particular block not to slide down or not to have that backward motion, because the friction will be acting as a locking agent, right? Because what happens is it's a very most simplest mechanism that we are using in many applications, and what is happening is what we are applying a small amount of force in order to lift a large or heavy bodies. And even if you're not applying this force, if you're not applying this force P, then also this heavy body will be at that position. Why? Because the friction force will be holding this block, and that is the reason we always call this wedge as a self-locking simple machine. Okay, so let us try to do the analysis by taking a very simple approach. And one assumption that I'll be taking is all the surfaces, all the contact surfaces will be having same coefficient of friction. That means here we are having this one and three. There are three surfaces where the body is in contact with where we are having contact surfaces. So we are assuming all the surfaces will be having same coefficient of friction for easy analysis. Okay, now what I'll be doing, I'll be drawing the FBD. I'll be drawing the free body diagram. I'm applying a force P. This is the applied load. This is your applied force, and W is the weight of that heavy body. Okay, so applying a force P such that this heavy block is being lifted up. So if I try to do the analysis, FBD analysis, if I only take that wedge, right? So because this is trying to move in the right hand side direction, we will be having a friction force acting in this direction. This is your, let us say, F1. So we'll be having one normal reaction over here, right? This is the applied force, that is P. And definitely this surface will also provide one friction. So this will be your friction F2, and this is your N2, right? Okay, now many students, what they do is they try to do the resolution of the forces, like they'll be taking all the horizontal and vertical forces. That is also a good approach, but I would rather say that is slightly tedious or lengthy approach. Instead of doing this, what we'll be doing is we'll be taking a very interesting concept of resultant of the normal reaction and the friction force. I hope so you remember. If I take the resultant of this two forces, if I take this as a resultant, let us take it as R1. Okay, so R1 will be making an angle of phi, where phi is the angle of friction. It's nothing but angle of friction. And just now I told you that all the surfaces having same coefficient of friction, that means mu is equal to tan phi. So if I know the value of mu, I can easily calculate the value of phi. I know this value of phi. Okay, similarly I can draw it over here. If I try to take the resultant of F2 and N2, this is R2 and this will be angle phi. Now this is having an inclination of theta. I think they have already given this is having an inclination of theta, right? It is already been given. So I can say if this is theta, the normal will be making an angle of theta with the vertical. Okay, so now what I've did is, instead of using 1, 2, 3, 4, 5 forces, I've just converted this 5 force into 3 force system. And if you are having an equilibrium condition, if you're having 3 force system, can we not use the Lami's theorem? right? So if I try to draw the three force over here, so this is your force P acting horizontally towards right. R2 is making an angle of theta plus phi with the vertical. So we can say this is your R2, the resultant of the two forces, making an angle of phi plus theta with the vertical, right? And R1 is making an angle of phi with the vertical. R1 is making an angle of phi with the vertical. Okay, so I have just converted this 5 force into 3 force. Now let us try to do the analysis of this heavy body. Now we'll be having a weight acting downward. This is the weight acting downward. Okay, weight acting downward. Now because the force P is applied, so definitely the body will be trying to move upward. So the friction force will be downward over here, right? So we'll be having, let us suppose this is F3, right? This is F3. So we'll be having friction force acting downward. This is your friction force, that is F3, and we'll be having normal reaction. Let us say this is N3. So we'll be having the resultant of these two forces, result of this normal reaction and the friction force, that is your R3, making an angle of phi with the normal reaction, right? Now let us talk, if I try to understand, when the body is trying to push and it is trying to move upwards, so definitely what will happen at this interface, the friction force will try to move in the downward direction. This is your F2 and this will be your N2, right? So if I try to take the resultant of these two forces, F2 and N2, this will be the resultant, that is R2, making an angle of phi with the N2. And this angle is theta, we can say this angle will also be theta. Okay, because this angle with the horizontal is theta. So what we have did, again the same analysis, I've just converted the 5 forces into 3 force system. If I try to draw all the 3 forces over here, so we are having W acting downward, we are having R2, the resultant force, making an angle of theta plus phi with the vertical, making an angle of theta plus phi with the vertical, and R3 is making an angle of phi with the horizontal. R3 is making an angle of phi with the horizontal. That's it. Okay. Now I can easily frame out the equation between P and W. Now if I want to apply the Lami's theorem, if I let's say this is your FBD of wedge, this is your FBD of the heavy body. Okay, fine. So over here, if I try to take this one, so applying the Lami's theorem, I can say P divided by sine of this angle will be 180 minus theta plus 2 phi, right? Equal to, because we are only bothered about this R2 reaction force, so I can say R2 divided by the angle between these two will be sine of 90 plus phi. Okay, rewriting this equation, I'll be getting P divided by, this would be sine theta plus 2 phi is equal to R2 divided by cos phi. R2 divided by cos phi. See, we got one relation between P and R2. Now let us do the analysis. Apply Lami's theorem over here. We can say W divided by the angle between these two forces, that is sine of 90 plus theta plus 2 phi, okay, is equal to R2 divided by the angle between these two. These two will be 90 minus phi, sine 90 minus phi. Okay, so rewriting this equation, we can say W divided by, this will be cos theta plus 2 phi is equal to, this will be R2 divided by cos phi, right? R2 divided by cos phi. So if you try to visualize these two equations, equation 1 and equation 2, we can simply say P divided by sine theta plus 2 phi is equal to W divided by cos theta plus 2 phi. Okay, and we can say P is equal to W tan theta plus 2 phi. Okay, so by this way, we have easily calculated what should be the magnitude of the applied force if W is the weight of that heavy object. Okay, provided we know the angle of friction and we know the angle of this wedge, the wedge angle, right? We know this wedge angle. Okay, now this formula is not, we can say, directly applied to all the cases. I've just taken a simple case over here. Might be you can get a scenario that the entire system is basically kept like this. The entire system is basically kept like this. Okay, so in that case, definitely your approach will be same. Your approach will be same, only the formulation might get changed. Okay, on the formulation might get changed, right? So that is the reason it's very important. Do not remember the formulas of wedge friction, only how to apply, how you need to apply the concept, that is important. Okay, so this is all about the concept of wedge friction. I hope you all enjoyed and you just understood how to do the FBD analysis and how easily we are using the concept of Lami's theorem to do the analysis of wedge friction. Okay, so thank you guys for joining with me. I hope you all enjoyed. So for more such awesome videos, stay connected with your own BYJU'S exam prep. Thank you guys. Bye bye. Take care. Stay safe.